Okay, ladies and gentlemen, I'm back. Today we want to talk about the properties of alkali metals. The properties of alkali metals. And besides that, we had said that the alkali metals are the group 1 elements in the periodic table. Group 1 elements in the periodic table. First, we want to talk of the general properties of these alkali metals. The general properties of these alkali metals, we can talk of the reactivity. Reactivity, when we look at these alkali metals, for example, if I list the examples of these alkali metals, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So when we look at the general properties of reactivity of these metals, they do not react in free state. Why do they not react in free state? Because they are highly reactive. Even if we look at the electron configuration of this metal, you find that as you move down the group concerning the periodic table, the ease of losing electron, the outermost electron in the energy levels of these metals is very easy. So that is why we are saying that these metals are highly reactive and they do not react in free state. Another general properties is that in terms of reactivity, alkali metals form strong alkali. Why are they forming strong alkali? Their oxides and hydroxide form strong alkali. An alkali is a soluble base. An alkali is a soluble base. So examples of these alkalis, we can say the sodium hydroxide, potassium hydroxide. So those are the examples of these alkali, the strong alkali that are formed by the alkali metals. That's a bit example. Then another general properties of these alkali metals, we can talk of when we look at the period 2 elements. They are basically known as the bridge elements. The bridge elements, why are they forming part of the bridge elements? Because they constitute to the diagonal relationship that we had talked about. So in those few statements, those are the few general properties of these alkali metals. Now we want to go deep into details. We want to talk of the physical characteristics. So the physical characteristics of alkali. So ladies, we want to proceed with the physical characteristics of these alkali metals. I'm sorry, there's a lot of distraction that is around here, so just pay more attention. So I'm going to start by talking about the atomic radius of these alkali metals. The atomic radius of these alkali metals, the atomic radius. So when we look at the structure of the periodic table, as you move from the group 1, as you move down the group, you'll observe that the atomic radius increases down the group. The atomic radius of lithium is less than the atomic radius of sodium, less than the atomic radius of potassium, less than the atomic radius of rubidium, less than the atomic radius of cesium, less than the atomic radius of what? Francium. So as you move down the group, the atomic radius increases. Why is it that the atomic radius increases? This is due to the low nuclear charge. So from here we can talk of atomic radius due to increases down the group due to the low nuclear charge. The low nuclear charge is what is making the atomic radius to increase down the group, or the large atomic radius. The large atomic radius. In other words, the atomic radius cannot be increased, but it is large. Large. The appropriate term to use there is large. The atomic radius is large as you go down the group. The next property we want to talk about the ionic radius. The ionic radius, when we are talking of the ionic radius, we will majorly focus our point on just the number of energy level. The number of energy level. So as you move down the group, there's a large number of large number of ionic radius of those respective metals as you move down the group. So our explanation there is based on the number of energy level. The more the number of energy level, the larger the atomic radius. So the third point, this one we have talked about. The third point is the ionization energy. So this ionization energy, or enthalpy, ionization energy. So first we want to start by defining this ionization energy. So the ionization energy is the minimum amount of energy required to remove an electron from the outermost energy level of a species in a gaseous state. So that is the brief definition of the ionization enthalpy or energy. So when we look at the ionization energy down the group on ionization enthalpy, the ionization enthalpy decreases down the group due to ease of that species to lose that electron. Now, as you move down the group, for example, if we have hydrogen, lithium, we have sodium, and we have rubidium, and cesium, and francium. So when you compare the electronic configuration of these, the outermost electron of hydrogen is closely attached to the nucleus. The outermost energy level of the outermost electron in the outermost energy level of lithium, the electron there is not firmly attached to the nucleus as compared to hydrogen. So when you find that as you move down the group, the ease of that metals to lose electron is very easy. So that's why we can say that the ionization enthalpy increases down the group. So we want to talk of the next property here, which is the hydration enthalpy. So the hydration enthalpy, hydration from the word hydration enthalpy. So a brief definition of this, hydration enthalpy is the amount of energy required or the amount of energy released when a species get surrounded by water molecules due to electrostatic forces of attraction. It's just the amount of energy released when a species get attracted to the water molecules as a result of electrostatic attraction. So it trends in hydration energy. Hydration energy is compared with the ionic radius. When the ionic radius increases, the hydration enthalpy decreases. So there is a way in which the hydration enthalpy is inversely proportional to the ionic radius. So that is the best term that we can use there. So the next point, we can talk of the oxidation state. All alkali metals exhibit an oxidation state of +1. And these metals, they are strongly electropositive. Electropositive means the ability of a species to lose an electron. So when we compare the electropositive character, the electropositive character increases down the group. The electropositive character increases down the group. Then we want to talk of the metallic character. The metallic character increases down the group but decreases across the period. That is what we can talk of that about the metallic character. Now let us move to the second last point, which is of the melting point and the boiling point. Here, the melting point and boiling point of alkali metals, we relate it with the RMM, the relative atomic mass, or the atomic number. So as you move down the group of group 1 element, as you move down the group, the metallic character or the melting point and boiling point decreases down the group because of increase in the atomic number. When the atomic number increases, the metal will have a low boiling point or melting point. And lastly, we want to talk about the nature of the bonds. Basically, the alkali metals, they mainly form the ionic bonds. They form ionic bonds. So this one we have talked about. So for those very, very few explanation about the properties of alkali metals, they are also making part of the S block elements, the alkali metals. So, but we have talked of these alkali metals. In simple terms, they are part of the S block elements, but they are referred to as the group 1 elements in the periodic table. So in the next lecture, we shall talk about the chemical properties of these alkali metals. The chemical properties of these alkali metals. Please be very close to my uploads and continue watching and subscribe. You will be getting more notification from my new uploads, and subscribe. Can advise your sister to watch for this. It is very helpful for her, and he will have all the knowledge that I'm manufacturing here. Be blessed.